So first off, thank you for coming out. I know it's kind of late in the afternoon. It's getting close to the end of reInvent, and I want to thank you for coming. Specifically, I'm kind of excited to see so many smiling faces here after quite a successful pub crawl last night. Hopefully everyone at least had one good cup of coffee before they made it to this session. Has everyone had one cup of coffee? Good. So we're going to be talking about big data, specifically building and deploying modern big data architectures on AWS. My name is Jason Woodley. I'm the Senior Director of Cloud Products inside of Datapipe, and with me today on the stage is Mr. Ilya Kramer.
Hello.
Together, we are part of the teams that are responsible for all of the external-facing products and tools that our clients at Datapipe use on a regular basis. If you're unfamiliar with Datapipe, we're out at booth 220. Shameless plug there. And we are a managed service reseller and managed services partner for AWS and other clouds as well. So to get us kicked off, these are a few of the things that we're hoping to accomplish today in our conversation. Like any good architecture story, we're basing it in reality. And the reality that we're going to be using is our cloud analytics product. We're going to be talking about some of our experiences with that, some of the architectural changes, and how we've refactored that to use Amazon EMR throughout its entire processing lifecycle. We'll also be showing some of our internal technical learnings along the way and some of our strategies that we utilize for testing in the cloud, as well as if you're currently looking to adopt these type of technologies, other things your organization might want to consider as best practices and how to help that transition. Additionally, towards the end, we'll be talking and giving some of our insight to what we think is the future for analytics and some of the emerging trends that we're seeing. So our story starts with Nuvum, acquired in 2013 by Datapipe. A startup like many others, that some of which you may actually be part of, they grew over time. Specifically, the cloud analytics product is one that you'll see here on the screen. It surfaces up insights that our customers use on a regular basis to try and make intelligent decisions about their resourcing in Amazon Cloud. Specifically, it allows us to pull in things that are security related for governance, as well as look at spending on RIs and other different key aspects of the platform. We're going to be using cloud analytics as our touchstone throughout this conversation to give you kind of some of our insights, how we grew with that product, how we changed that product, and how we refactored it to be more EMR-centric. So let's start at a point in time. I want to share with you kind of the architectural time capsule that was Nuvum when we first brought that product into our company. The platform was made up of multiple disparate applications, a lot of little small standalone ETL-type tools that would feed it. It had heavy utilization of agents and APIs, making multiple calls to instances, to services, and things of that nature. The key performing mechanism for making these calls were queues and high-frequency polling. Anyone who's had to write systems like that can tell you the types of pains that you might actually encounter in that. And as a database layer behind it, we were making use of MongoDB. And there was a lot of heavy concurrent activity against that, some of which was semi-real time. So you can imagine, as we started to dig into this, we started to map it out. And just to kind of share with you a little bit more insight of what that looks like, the following architecture diagram probably looks very similar to systems that you've worked on 1,000 times. In the upper left-hand quadrant, we have a presentation tier. Multiple AMIs, in our case, Django as a platform for MVC and building out the UI screens that feed the product. Sitting behind elastic load balancers for scale. And then behind that, you would have your data layer. In this case, we had split our MongoDB instances between financial reporting databases and detailed insights. What was a little bit more unique was this right-hand side. And I kind of labeled that approach as opposed to tier or service or anything like that, because I wanted to kind of drive home the point that this wasn't just one little application or service. In fact, in this particular application, it was about 30 plus. So what effectively was going on is in this environment, you had lots and lots of little VMs or instances hanging out there. And each one of them was running a piece of code that was very, very similar, but not quite the same. You had some kind of a capture approach. It was going out, it was talking to APIs. It was pulling things out of S3 buckets. It was talking to agents. It would take this data, bring it in, oftentimes having to decompress it, do some kind of file level manipulation on it. And then it would kind of walk through this data, this large chunks of data, extracting entities, and then feeding the beast that became our data tier. In doing so, it would start to build this picture of the data, effectively building time series type data so that we could process it and build larger level insights and aggregate it later on. This, not quite sure, is that a phone? That or we have a bird loose in the building. So the delta processing would come through and would actually start to churn through the data in the database with the newly discovered insights, processing, aggregating. And what was interesting is we had these 30-plus little instances hanging out there doing all this work, all fighting for contention on the MongoDB infrastructure. At the same time, we also would have clients and end users starting to drill through the databases with screens. So what we discovered is we have, what many of you may have in this room, a big data problem. Multiple consumers, dashboards, aggregation reports, query interfaces, real-time interaction by clients. We're all going against our data infrastructure. At the same time, we were also pumping in more data into the data infrastructure. In many cases, 2 gig plus files from each of our 1,500 clients on a regular basis were being pumped in, going through those little ETL approaches and services that I mentioned earlier, being churned through at a regular clip on an hourly basis. At the same time, we also had thousands of large API payloads being processed per second also in through the ETL layer and into the database layer. This all sitting in this VM nightmare of distinct ETL processes. In order to try and feed this, we basically scaled MongoDB instances about as large as you possibly can and had multiple of them. The goal being there to try and give as much horsepower to the indexing and the aggregation as we possibly could, trying to serve the two masters of data aggregation and translation at the same time as our end consumers who needed access to it. Has anyone ever experienced a problem like this? Kind of gets painful, right? Yeah, a few hands and a few scars, right? So as you would imagine, we started to experience more issues. Processing was slow. It was error-prone. Our infrastructure was mostly static. Significant number of single points of failure, which made maintenance a nightmare. As you would imagine, with so many disparate little chunks of code, release management became very, very problematic. Important to note, our data store was our primary bottleneck, both to the ETL, the aggregation, and our end consumer. To top it all off, trying to work around this by just pouring more money in it wasn't working. The always-on MongoDB infrastructure became extremely expensive. In the end, we started to realize that our spending was really aligned around this Mongo infrastructure. Now, I personally am a fan of Mongo, but it's not the right tool for every possible problem. Our spending was aligned around this infrastructure, trying to overcome some of the inadequacies of pushing all the ETLs into it and serving both masters at the same time. And one of these type of architectural meetings, which I'm sure we've all been in, where you're trying to figure out what your next avenue of attack is, I think it was probably Ilya who brought up the point that specifically, why are we spending so much money on what is essentially data at rest? The key concern for us is that a lot of our clients would come in. They would get valuable insights from the tool. These insights would be achieved in 2, 3, 4 seconds, and looking at a couple of reports, and in the new pattern of managed by exception, it was right there with a big red sticker that said, go do this, and they were done. But in order to achieve that value for them, the ETL processes, the Mongo infrastructure, things of that nature were churning 24/7, going through a lot of data that was effectively never really used once it was aggregated more than once or twice. So we were paying for data that was sitting at rest in the Mongo database infrastructure. So we started to think, how can we change this picture? How can we re-architect? And in this journey to get cloud analytics to it, we started to outline our goals, as I'm sure you've done in many projects. They factor around 3 core areas: our analytics, our data layer, and our support footprint. Our goals were to improve performance, making it faster for us to achieve the same level of result for both our client and our internal processing. Increase our scale. As the product was growing, we wanted to make sure that we could support thousands more users and thousands more environments. In this particular product, for our customers, we go out and we pull all the data from all their billing, all the data from their performance, all the data from their logging across many, 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 many large AWS environments, thousands plus node level environments. So as we were pulling this through, we actually wanted to reduce our cost and be able to increase the analytics proficiency. And the other big concern we had here was our data layer. How do we get more performance out of this? Of course, the natural question was, is Mongo the right tool? Is Cassandra the right tool? And how do we reduce the cost? At the same time, managing this environment with all these disparate apps was becoming extremely problematic, not to mention all the different instances that might need to be updated when patches and things needed to be applied. So as we started to do this, we started to re-architect. And our re-architecture was focused on a few fundamental areas: separating out our raw data and our user visible data. So by that, a large part of our spend, a large part of our processing was pulling down all of this stuff into a form, in this case in MongoDB, that we could churn through, aggregate. That really wasn't visible to the user. What was visible to the user was, hey, you're out of an average or a tolerance or things like that. But by trying to think of them as 2 disparate use cases, we were able to refactor the application to support them as 2 disparate types of processing engines. In doing so, we aggressively looked towards Hadoop. And with Hadoop, EMR being a prime contender. In the end, we refactored a lot of portion of our ETL process, not to take data and put it into Mongo and then aggregate through it, but instead to unify a lot of these little ETL processes to create files that can be on S3 and easily digested by EMR, effectively giving us a pattern that we could churn through all of these files at our leisure in very quick and fastly scaled jobs. We also looked at the nature of the data that we were pulling. When the product was first created, it was a little different world. Some of the stats that were available now with CloudTrail, CloudWatch, and other such things were not available at the time. And as a result, we had a dependency on agents that would have been in some of the different pieces of the infrastructure. Pulling all these different environments was very costly and time-consuming. We took a very long and detailed analysis of this and ended up switching many of these to be utilizing AWS services. We also looked very detailed and did a lot of testing around the infrastructure itself. Did we want to maintain and manage? A lot of people move to the cloud, and the first thing they do is say, whatever system that we had that was physical, we're going to take and build the same exact system inside of the cloud. It's not the right approach 90% of the time. Going to the cloud means rethinking what you've done. So one of the things that we had to rethink was our infrastructure investment. Before, we had managed MongoDB environments directly in the cloud, very large instances, things of that nature. And our first step into this was, all right, how about Hadoop? Let's make a Hadoop instance. And we started building out Hadoop clusters and Hadoop instances. One of the big challenges there is management of that infrastructure. Now you're going to have a lot of people going around worrying about which version and what kind of patches and updates and tools and configuration. And eventually you're going to get to a point where you're spending a large number of resources and dollars on this infrastructure that, again, you're not using fully. So we looked very detailed and made a conscious decision to move towards more on-demand infrastructure. And finally, we looked at the things that our users were actually going to be using and moved those pieces to SSD-based infrastructures so we could have faster performance for that. Because now we had less data. We could actually accomplish that for our clients, and as a result, have a faster system. Also keeping in mind TTL on that data so we could delete it and no longer keep it around forever. So that's how we re-architected. And along the way, we discovered a few things, and I'd like to share a few of them with you. How many of you right now are already using Hadoop? Okay. So a couple of you are, I would assume everyone else is thinking about it right now, or you probably wouldn't be in the room, right? So here's a few learnings that we achieved over the way. Hopefully some of them will resonate to some of the people who are old hats, and some of the others may actually prevent you some pain. So, first off, resource alignment. Back to that question of, do you manage your own infrastructure and just put it in the cloud, or do you use more of a service level approach? The following is just kind of a rough snapshot of some of the analysis that we did along the way. Specifically, we looked at both a static instance in the cloud, running Hadoop, versus EMR jobs. And our usage pattern, we looked at a M4 X large there, and we found that our usage pattern would have been somewhere around 20% of the time, or about 4.8, almost 5 hours. And that would have yielded us a monthly cost of about $800. But looking at this on EMR, we were able to go with wider clusters that were transient in nature. You could spin up jobs. Now using things like the data pipeline, this is even easier. And as a result of some of the ability to split this a little bit wider, we even trimmed some of the time that we would actually need it. But looking at kind of a base mark of about 4 hours, you came in at around $170 a month. Now that's a significant savings. If you now start to scale and prorate this out by a large and fast-growing environment, that gets even more. Another key thing that we started to understand about working in this new world is always looking at exactly the right tool for the job. If you're embracing big data technologies, you're looking at Hadoop, you're looking at EMR and other such things, there is a rapidly exploding ecosystem of tools and techniques that will allow you to accomplish very, very similar things. As a result, for our processing and analytics churning, so to speak, we looked at multiple. One of which being the most common pig. I'm sure that if you've been looking in this space, you've probably heard pig a few times. And then, of course, MapReduce in and of itself. Pig itself is a higher level order tool that kind of puts a veneer over some of the complexity of working inside of MapReduce. If you come from a background of heavy data-intensive systems and maybe Oracle or SQL Server is kind of your go-to tool, Pig may feel a little bit more familiar. It has syntax that smells a little bit like SQL, not quite as much as Impala does, but it gives you a little bit of a familiarity. And you're like, hey, that one slide on the left, that screenshot with the S3 bucket, that's kind of somewhat readable, but the one on the right, maybe not so much. So as a result, most people tend to stay more towards the newer tools like Pig. One of the things that we found with that, though, is that Pig in and of itself gives you only the ability to process one pass through the data before you then hand off to another job or task or pass data back and forth. Where going directly to MapReduce, you have the ability with kind of a micro mapping concept to get multiple chunks of data and process multiple things on that same single pass. Now that may not feel like much to kind of at the surface, but what that gives you is the ability to make most of your analytics work in a single pass architecture. Now granted, it might not be as readable, but most any of the developers who've spent any time in Java or Scala or anything like that can naturally kind of pick it up with a little bit of elbow grease, so to speak. For us, it was a significant savings. In fact, we were able to take 90% of our data through and aggregate it in single passes as opposed to multiple passes through, which overall gave us about a 40% performance improvement throughout the system. The other key thing is if you're coming from classical database architectures, you're probably very familiar with joins and lookups. It's kind of the staple. As soon as you learn about relational integrity, you want to kind of get away from it by pulling it all back in multiple forms. Hadoop doesn't really work in the same way. You really want to avoid those type of lookups because they're going to kill your performance. In fact, it's better to kind of pipeline your data and combine it. Here on the right, this little screenshot is just kind of an exemplar. Okay, if you had two different data sources, they may come from different types of places, but if you merge them together, then you're able to pipeline this data more efficiently and reduce a lot of the bottlenecks that occur in the engine. For us, these results were significant. Through re-architecting in this way, moving to EMR, and going with a transient infrastructure as opposed to static, we were able to reduce our cost by 80% and improve our processing by reducing it by 75%. Overall, improving both the stability of the product, attaining our goals, and making it faster. It's not very often you get to go to your manager and say, yeah, I made it faster, cheaper, and better at the same time. So the other thing that we learned along the way is that testing has to be viewed differently inside of this new world with big data. The older methods of just basic unit test and simple integration test really weren't complete. The reason being that in order to attain a full valid result, you need to have the amount of scale of data to truly do a performance level integration test. So we found that some things didn't quite show up. Some benefits of scale did not show up until you had enough data in there to see it. So a couple best practices started to emerge. Rapidly, the team started to develop approaches, scripts, and tooling to allow them to create new environments, copy over large data sets in S3, spin up and test things, and spit out different reports. We developed differencing strategies so that we could easily look at past runs of data against newer runs of data, looking for those variances to help out both developers and QA people. Other key things are starting to emerge in this space, such as code pipeline and data pipeline from AWS that will actually help this even greater in the future. Organizationally, a lot of you may be here and you're trying to digest these new technologies and figure out where it fits. You know, it's the kind of technology you don't really want to just pick up because it's hot and fresh and on the cover of CIO magazine. You really need a business case that actually has enough teeth to force you here, because it's a significant learning curve. For us, we had a real-world problem. We had all this database contention. We were doing aggregation. We had a spin that was out of control, and the type of processing that we were doing was a natural fit for these technologies. So it's key to make sure that that business case is there. And then you should look inside your organization for early pioneers. What we found is Ilya and other people like him were leading the charge saying, you know what, this smells like a problem that can be best solved with Hadoop. Let's do some investigation. With these type of projects and this type of technology, the best way to learn it is to kind of get in there and start flexing your muscles and figure out what's working and try a few different scenarios. Because to optimize this, it's a little different than optimizing like a SQL query. The rules aren't fully written for everyone. Adoption of these type of stacks are much more complex. When you're thinking about your teams, expect that ramp up is going to be slower. In order to achieve that level of ramp up, you really need education, and you really need time in order to let them kind of explore and dribble the ball a few times and miss the shot. The other key thing that I want to stress is Amazon EMR is very, very handy for prototyping and helping you along the way. It's easy to keep 2 or 3 months of large data sitting out on an S3 bucket, allow your developers to ramp up and start new jobs. In our classical environments where we had Hadoop infrastructure, we were always fighting, okay, well, the 10-node cluster, it's in use by developer X. How do we partition that so that we're not stealing the CPUs and resources? And with EMR, it goes away. My job is running. It doesn't affect your job. Go run your job. Very easy to explore these things. The other thing you may be thinking about is, well, where is this space going? We've shared with you a lot of our thoughts and a lot of our pain points, and along the way, we've picked up a little bit of insight. We do see the world changing in this space. It's a very large ecosystem, and it's very new. As a result, in Hadoop, there's a tug-of-war of vendors and tools. I'm sure everyone in the room knows things like Cloudera and some of the other competitors in that space. We've used some of them as well. Frankly, most of them are having a hard time keeping up with what's going on in Amazon these days. The BI vendors and the platform providers that you may be familiar with, such as Cognos and Information Builder, as well as Tableau, are already ahead of the curve when it comes to visualization against Hadoop. I think that they're going to continue to have kind of a dominant position and grow in this space. There's a few startups and competitors that are coming in here, but for the most part, the visualization vendors have been doing it for a very long time and doing it well. A couple key areas of pain. I know specifically if you're trying to do it in your own infrastructure, these pain points will differ. So if you're using open source Hadoop versus Cloudera or even EMR, they're going to be drastically different. Specifically areas of job management, how jobs inside of multiple chain talk to each other. Uzi is definitely one of the top choices here in the open source community. Reporting is always a challenge, as well as log consolidation. Ganglia is a key tool that's very helpful if you're doing it on your own. But the one thing that I would say is if you're going the route of Amazon and EMR, a lot of this stuff is starting to be baked into the products already. So you have log consolidation. You also have the whole scheduling pipeline. Now with the data pipeline stuff that's out there, you can really accomplish some great things without having to go through some of the pain that exists in kind of the nebulous market space. Also, additionally, the world is starting to have more and more managed service providers in this space. Inside of Datapipe, we are a managed service provider and a large partner. There are many others that are out there, but we do have a strong dedication towards Hadoop, and we have a large number of trained resources who are out there helping people set up environments, both static data centers and using it in the cloud. So I think the field will start to narrow there, and a few people will start to stand out. So that was pretty much the end, guys, and I wanted to thank you for your time. If there's any other additional questions you guys would like to raise, I did reserve a few moments if anyone wanted to ask any, or if you wanted to come up a little bit later. Okay. Well, please feel free to complete your evaluations before you go, and have a good time at the party later tonight.